Good morning, everyone, and welcome to Autodesk Virtual Academy, presented to you by Cative Technologies. I'm Nigel Mbayak. Sorry I don't have a camera today. I'm actually in Portland, Oregon. So for those of you who are going to be at the Inventor user group meeting tonight, definitely come say hi. I'll be there. And I'm actually joined today by Alex Alvarez, who's on the other side of the line. Alex, how's it going?
Hey, how's it going, Nigel? Pretty good.
Nice, nice. Hopefully you guys don't miss me too much in the Brea office. But yeah, so today we're going to be going over the product design and manufacturing collection, right? As well as, touch base a little bit on the AEC collection as well. And so for those of you who don't know what it is, it's kind of the next evolution to these things that were once called suites, right? So there used to be product design suite, factory design suite. There were something like 21 different suites you could get because there were like 6 suites and then 3 tiers for each one. 7, I guess. So anyways, they've kind of simplified the packaging, right? So they've released one for the entire manufacturing space, one for the entire architecture, engineering, and construction space, and then one for the media and entertainment space. So today we're going to be focusing on the PD&M collection, which is, if I say that a couple of times here, that's just an abbreviation for what's on the screen there. Like I mentioned in the emails that you probably all saw, there have been a couple of additions over the last month into the collections, right? So in the PD&M collection, they've included both Nastran In-CAD and Autodesk HSM. And so what HSM is that's a CAD or CAM tool that Alex will be going over pretty shortly here. And then Nastran In-CAD is what is being used for simulation, right? So you do have your integrated Inventor simulation that comes with just base Inventor Professional. But Nastran In-CAD something on top of that, right? So both of these products used to be available externally from the collection, right? But they Autodesk decided that, hey, we're going to include these. But it's not just an inclusion of like putting more stuff in the software. Really, they wouldn't have done that unless there was a reason as to why they did that, right? And so we're going to go over some of those workflows. It's just not more software for the sake of more software. It's more software for the sake of, hey, like everyone using this group of products can definitely benefit from using integrated simulation and CAM in their workflows. Almost everyone, certainly. So they included it for that reason. So if you have any questions today, definitely go ahead and type them into the chat panel. Alex and I can go over them as needed during the presentation. And definitely we'll stop if needed for answering a couple of those. So do you think I missed anything there, Alex? I think we're good to go.
No, I think you pretty much covered it all.
Awesome, cool. So let's go ahead and jump into this. If you, in addition to that, if you do want, more picks and clicks and how to use these tools, we'll talk about some training opportunities we have, as well as, some resources you can use to go ahead and find things like that, right? So let's go ahead and move on here. So go ahead and spend a couple of seconds reading these four questions on the screen. These 4 are some pretty common questions in industry of manufacturing that people ask of themselves, right? So I'll give everyone a minute to read some of these and, go ahead and see if any of these relate to you and your organization, right? I'm willing to bet that almost everyone on the call kind of fits into 1, maybe 2, sometimes 3 of these. Let's go ahead and move on real quick. So I'm not going to pretend like I have all the answers to those questions, but what us, as well as Autodesk, have done is, we've created a tool set, right, that aims to unlock all of the potential for you and your organization, right? So there's 3 things on the screen here. And there are 3 ways that we can accomplish, kind of opening the floodgates and being able to unlock your potential, right? The first one being common tool set, right? So everyone has the tools they need to be effective and to innovate and just, you've got the right tool for the job, it's all included, right? Second off, shared information, right? You want to ensure that everyone's using the same information, the same data. You want to make sure that, the people have the right access to the right things at the right time, right? So things like Vault is really good here, as well as, there are some other tools as well for cloud storage as well if you wanted to use that. And lastly, collaboration, right? And so that's where Nastran In-CAD and Autodesk HSM come into play, right? So not necessarily collaboration between you and your coworkers in regards to communication and working on the same products at the same time, but collaboration in regards to the streamlined workflows, right? So Nastran In-CAD and Autodesk HSM are truly, quote unquote, in CAD, right? So they're fully integrated into Inventor. And we'll show you that pretty shortly here, kind of showing you a little bit of the interface into both. So it's as simple as, just sending your assembly file or sending your part file to somebody and then being able to open it in their Inventor and utilize some of these really high powerful simulation and manufacturing tools just built into the programs themselves. Cool. So we've got a little bit of a product matrix here, I would say, showing all the products. Right here, what you have on the screen right now is everything, just about everything that was included in traditionally product design suite, Ultimate pretty much. And so you can see those two gaps there. They're going to get filled here pretty shortly once I hit this next button. Autodesk has included Nastran In-CAD and HSM, right? So you don't just have Inventor and you don't just have Nastran and HSM, but you have tools, you know, to get through your electrical processes. With electrical, you've got full-blown factory design utilities. We'll kind of expand on that a little bit as well. And you even have things like Vault Basic, right, for your data management. And this is actually the only way to get Vault Basic now is through a collection in regards to getting new Vault Basics. So that's actually a really useful thing for those people like that. But definitely Autodesk has strived to create their best Inventor, quote unquote, which is why they've included things like Inventor, HSM in Inventor as well as in CAD. Right? You might be asking yourself, like, hey, I do have the product design collection myself. How do I obtain these tools? If you jump into your contract manager, so probably your CAD manager or software coordinator, maybe sometimes your IT in these cases, whoever's assigned to that contract manager role for your organization for the Autodesk software will be able to open their accounts. There's a tab in there that says product design collection, and you'll be able to access these tools straight away in there. If you're confused as to whether or not you have them or not, definitely go ahead and call our Lifeline team, and my colleagues or myself will be more than happy to kind of show you around and figure out first and foremost, hey, do you have a suite? Do you have a collection? And things like that. In regards to the transition to suites and collections, right, that question came up a lot, and I'm sure, Alex, you probably got a couple of emails. Eric is also on here. I'm sure you got a lot of emails as well. It's like, what's the difference between suites and collections, and how do I get to a collection from a suite? So Autodesk has created an easy workflow, not workflow, I guess, transition from suites or perpetual licenses into collections. And they give you a pretty significant discount when you do so. And that's called a maintenance subscription. Maybe one of your sales representatives have talked to you about what is called M2S. Essentially, you trade your perpetual license in and you get a huge discount on a subscription license of the same product, or if you want to jump up to like a vertical, going from something like an Inventor to a full-blown collection if need be. If you need more information on that, let us know. We can get you in touch with your sales representatives or renewal representatives, and we can figure that out as well. There's a lot of details on that, so we can go over that with you. Cool. So let's go ahead and jump into a couple of things. Like I mentioned, there's something for everyone, right, in the collection. For your engineers, you do have access to your 2D tools like AutoCAD, 3D tools like Inventor. And for your analysts, right, these guys can traditionally have jumped into things like ANSYS or some really high-powered simulation tools. Well, Nastran In-CAD is built right into the collection, and it's an easy workflow from Inventor. We'll show you exactly how that works here pretty shortly. Alex, if you want to go a little bit, go ahead.
Yeah, I was just gonna say that this goes back to the collaboration aspect that you were talking about earlier, right? Bringing the engineer and the machinist, in my case, together. Now they don't have to learn, two completely different tools. Now, being that HSM is integrated into Inventor or SolidWorks, you have that ability to work within the same tool.
Exactly right. It makes a lot of sense. And I know like a big pain point for people, as well as for me when I was working on a lot of these simulation projects and stuff, was, if the geometry of your original product changed, how would you get that all the way to your analyst? Or how would you, communicate that downstream to your machinist, right? So traditionally, you would have to get a completely brand new CAD file from somebody, sometimes step files even, because they can't read the native file types. I'm sure, Alex, you've seen it a ton of times where a simple change in geometry kind of blows up your whole thing. Traditionally, you'd have to do a brand new export out of CAD into your CAM tool and do that. Whereas here, it's fully integrated, right? So if you do make a change in geometry, it does take account for a lot of that change, especially in the CAM aspect. And Alex can go over that a little bit, where the toolpaths will auto update for you. You'll understand that, hey, like this edge changed in regards to the sizing and stuff. So anything else you want to add there, Alex?
No, you pretty much covered it there.
Cool. Awesome. And then your factory planners, right? We'll go over this a little bit. Factory design utilities are built right into Inventor, right? With the collection, you do have access to the factory utilities, which gives you a full catalog, I guess, of commonly used factory parts, right? Things like conveyors, things like racks, welding tables. There's hundreds, if not thousands, of standard components built into there, something like similar to the content center, except it's like full-blown components. And you can, there's an easy workflow between things like AutoCAD Architecture, Recap, Inventor, and Navisworks. So you can be able to visualize these things at the end. Cool. So we'll go over a couple of examples here. Let's go into a scenario, right? So your engineers traditionally, hey, I'm going to go ahead and build this assembly. I'm going to go ahead and build these parts. But, somewhere where these linkages come into play, there is a lot of stress in those areas. And I don't want my parts to fail, right? You don't want it to be 6 months later when your part's actually on the shelves and you're getting things like field failures. You're having a lot of warranty issues, a lot of recalls and things like that. You want to kind of avoid those at all costs. Pretty, straightforward. And so how do you do that, right? You utilize simulation early in the design workflow to do so. And it hasn't been this easy ever in regards to running simulation. So even things like static stress, which you've traditionally been able to do in Inventor, you can do thermal simulation, you can do fatigue, which is a huge one. How many cycles is it going to take for my part to fail? It's going to go through X amount of cycles before it breaks, which is cool, because if that number is, sufficiently high enough, then you're understanding like, oh yeah, my part's not going to fail for 100,000 cycles. When you don't even imagine its life to be that long, you should be good to go. But imagine if it was the other way around and you didn't test it, right? You've got a bunch of parts failing in the field. You're going to have to send technicians out to do like Band-Aid fixes and stuff like that. Whereas you could have, done that at the beginning of the design process. Or even some people, they come to me, it's like, we don't need to do simulation. We build our parts like huger if we think that we've got a need for that. Traditionally, the phrase, I don't know, Alex, if you've heard this before, it's like, when in doubt, build it stout. So just like, let's just build it bigger, it'll be fine. Sometimes you don't build it big enough. I've seen that a few times, and it doesn't end up well for a lot of people. So definitely utilize simulation early in the workflow, and it'll help. So engineers will traditionally work on this. They'll go ahead and send that to their analysts, right? And with Nastran In-CAD, there is no need for file translators. It's as simple as, loading something like this into your Vault and having your analyst pull it down from Vault and start working on it. I'll show you exactly what that workflow looks like directly in Inventor here shortly. Your analyst can go ahead and work on these things, and you know what? They think that there might be some issues in some of these areas. They're going to send that information back to the engineer. Traditionally, things, when you're working in foreign products, not foreign, I guess, non-native products, you would take screenshots, you would, print reports and stuff like that. You'd send those back to the engineer. In this case, when you're working in Nastran In-CAD, right, those results remain with that part, right? It's an attached file. It's kind of like it's a child, right, of that assembly or part file, and so it remains with it even through Vault and things like that. So that's easy to send back to the engineer, right? The engineer can go ahead and interpret some of these results, as the analyst probably has already, and decide whether or not they want to make a change to the actual geometry to kind of get rid of some of those stress concentrations, maybe add a fillet here or there. For things like thermal, they might go ahead and look at some of the materials they're using. But it's a lot easier to communicate those simulations when you're working in the same tool, right? Never get disconnected and things like that. If you want to go ahead and update the geometry or update a material and send it over to your analyst, it's as easy as going ahead, doing that in Inventor, and saving the file down. They can go ahead and get it again, and the simulation should still be pretty much intact and easy to run again. So we'll go ahead and open up Inventor here real quick and run through this real quick. Awesome. So we got Inventor Professional here. Looks like we might have a question. I'll go ahead and open that too as well, and we'll make sure that we get that taken care of as well. Okay, cool. So we have Inventor open. I'm sure everyone's pretty familiar with this workspace. I'm in an assembly right now, so I've got my assembly tab open. Traditionally, when you go to do the just Inventor Professional simulation, right, you go ahead and open your environments tab, and that's right here. So I'll slow down. I know my internet connection is not the fastest right now. Just make sure everyone can see what I'm doing. So I'm going to go ahead and click the environments tab. And as you can see, all of my separate environments are in here, right? This is something for a lot of people don't necessarily look at. There are a lot of analyses tools in here, as well as things like cable harness and tube and pipe. So over here to the right, this is all traditional like Inventor analysis for Inventor Professional. But what we really want, right, is Nastran In-CAD. So we're going to go ahead and click that. So Nastran In-CAD is right here. We'll go ahead and jump straight in. Awesome, cool. So since I've already run a simulation, there are some results already running through here. And if you are attending the user group meeting this afternoon in Lake Oswego, I'm already in Lake Oswego, but you'll see how I set up this this entire simulation. Kind of tested this this weldment here to make sure that everything's good to go once I load this this U-joint right here. But anyways, we'll go ahead and look a little bit into the interface, right? So like I mentioned, Nastran In-CAD does have a ton of different analysis types. So you can just run new analysis. Let's see, did that come off my page? It did. All right. Anyways, I'll move off of that. How do I figure this out? Control-Shift-M. Looks like I've got a window open on my other page. So what I'll do is I'll go ahead and close out of Inventor real quick, and then I will jump back in. It looks like I opened a window. It's on my second monitor, but I don't have one connected right now. So let's go ahead and do that. And we can just jump back into that. Sorry for that, everybody, but happens sometimes, right?
Always when you do a webinar, right, Nigel?
It's sometimes during a webinar or a demo, right? But it's no worry. Yeah, we just had a dialog box open on another screen. If that happens to you in Inventor, you can go ahead and open another session, or even better, you can go ahead and change the screen resolution. So I guess I turn this into a support case, right? You can go ahead and change the screen resolution on your computer and change it back, and then everything will jump back over if this happens to you. Cool. So I'm going to go ahead and open Nastran again. There are a bunch of simulations you can do. Obviously, in this case, I do have static stress simulation. I can do some fatigue if I really wanted to. Things like thermal, probably not too applicable in this case. But all of those are available to be run through here, right? So you can run your linear, you can run your nonlinear drop tests, and things like that. You can do composite materials in Nastran In-CAD. It's super, super powerful in that regard. So generally, when you're working in a simulation tool like this, you work like you do in Inventor, right, from left to right. So you can change your settings. You can create new simulations. I'll probably do this later. Or you can even import from stress analysis, right? So if this is something that you've been working on for a while before you had access to In-CAD, and you have some results from Inventor, if you just did Inventor Pro simulation and static stress, you can import some of that information into Nastran, right? So things like your constraints and your loads and your connectors, and a lot of the idealization is already set up for you. And then you can use the Nastran In-CAD tools to kind of simulate through that, right? So I've already run this simulation. It takes a while to set up. If you do want to know how to set this up, this file is actually in some of the quick tutorial files for Inventor. So you can definitely search for this hanger weldment. If you just Google that, you'll be able to find this tutorial and run through it yourself. I've done some other things besides the tutorial, but it is a good data set to work off of. It kind of shows you a little bit of everything when you're working on this. You can set up materials, idealizations, right? You want to be able to set up physical properties for these things. And you want to be able to select what kind of elements you're using. So we'll go ahead and talk a little bit about elements, right? And so how all of these simulation tools work, if you aren't familiar, finite element analysis, you take one big problem and you turn it into hundreds, if not thousands, if not millions of small problems. And that's the way that I was kind of taught how that all works, right? So instead of creating one beam, right, you split that beam up into hundreds, if not thousands of beams and solve those individually to be able to find displacement and stress and stuff like that for those areas of need. You've got constraints, you've got loads. This is all pretty standard, right? So constraints, similar to Inventor, right? When you're constraining things, you're going to want to constrain this. So things like these mounting holes, right? They're not going to move. They're going to be pretty static. And loads, you generally, for this, I'm going to apply it to this top half of this U here as a distributed load across that surface. You've got contacts, so you can kind of choose how these things are all connected. In this case, these are welds, right? And so that's how I chose that. In regards to the mesh settings, I think this is where a lot of the intuitive knowledge comes from, things like In-CAD and things like simulation in general, right? You want to make your mesh finer in those areas where you've got, areas of note is what I like to say. You want to make your mesh a little finer so that you do have more accurate results in those areas. If you have an area that's really far away from any stresses, you don't think that anything pretty crazy is going to happen there, you can make your mesh a little coarser in those areas. So for example, right here, all of these red areas are a little finer than the green areas, especially right here where the welds are. I think I have highlighted right now. Connect this gusset to this angle, and this weld that's connecting this U-bolt to this angle as well. I think a lot of stress is going to happen in those areas. So I'm going to go ahead and make that mesh finer, right? So I get more accurate results as to, you know, things like hand calcs, which is something I definitely don't want to do for this, because that would suck. Alex, would you agree?
Absolutely, and I like how you pointed out too that you made the mesh a little bit finer along those fillets there for the rib, and then oftentimes you want to know, right, if you did get the correct size fillet, or if you maybe need to go a little bit bigger on that fillet as well.
Right. Yeah, you want to go bigger on that weld bead or things like that, right? So these are all things that we teach during our training class. Katif does quarterly Nastran training classes. We go over things like this, best practices, how to simplify your model for simulation too. That's a huge one, right? You want to make your model as simple as possible so that you're not using a bunch of computing time, right? So something like this took me about a minute to solve, right? But if I wanted to do something crazier, it would take a lot longer, right? You do have results as well. I'll go ahead and run this while we're talking as well. It doesn't take very long actually for this. I simplified it a lot. When I did it earlier, it took a ton of time. But you don't need a supercomputer anymore to test these things, right? Traditionally, maybe even like 5-10 years ago, you would need a supercomputer to kind of test a lot of this stuff. And a lot of people weren't really using a lot of simulation. In this case, you know, it's not too taxing on the machine. A lot of people ask me all the time, and it looks like that question did come in through here. Can you use this as cloud simulation? So as of right now, Nastran In-CAD is not available to be run in the cloud. Essentially what that is you're using the computation power of like a Amazon web server to do everything. With Nastran right now, you can't do that. That's something that's definitely in the works though as well. So let's go ahead and look at some of these results, right? So you get things like displacement, you get things like stress, strain. Obviously these change based on the simulation you did. And you can figure out, you know, you do have these contours that are able to tell you your minimum and maximum. And you can go over a lot of these in the options as well, right? So you can go ahead and choose like, hey, you know, I don't really want zero displacement. I want to show anywhere. I want to show a certain range. And they'll be able to find some of that information for you. You can do animations, things like that. These are all things we go over during our class. Obviously, I can't go through them all today. We don't have a lot of time. And we have to go over the CAM environment as well, or else Alex will get mad at me here. So it's pretty straightforward. If you do have any questions on how all of this works, it is a super powerful simulation tool. It is available to you. Definitely want to let everyone know that for those people who do have collections. And the transition to get to something like this is pretty simple. So I'm going to go ahead and close up Nastran In-CAD right now. We do have numerous webcasts on how Nastran In-CAD works and how to do certain simulations. So if you are interested in that, go ahead and check out our YouTube channel. That's youtube.com/Katif Technologies. We have a lot of that information for you. Let me go ahead and jump back into the PowerPoint here. And I'll go ahead and answer a couple of questions, right? So let's go ahead and just jump forward real quick. Awesome, cool. So let me go ahead and open these questions real quick and take care of some of them. Awesome. So we got a couple of questions. I have Product Design Suite Ultimate on subscription. Will that transition automatically into a collection? I don't believe so. I'd have to double check. Product Design Suite Ultimate on subs is a little bit different than perpetual licensing. That's something you probably have to talk to your sales representative about. But if my best guess would be that for the remainder of your subscription term, you would keep your Design Suite Ultimate, and then after that term, you can go ahead and jump into a collection. So that's that one. So cool. If you do have any questions, definitely keep them coming. We're going to go over some of the CAM stuff now. And I guess it's my time to turn it on to Alex. Alex, do you have anything to start before we get started here real quick?
No, you pretty much, that was a pretty good explanation of the static stress that you did. Yeah, so now focusing over on CAM, right? It's really a similar workflow to what Nigel just explained, in the sense that it's you get that integration, right? And that's something that Autodesk really wanted. They wanted the design and manufacturing phase to really be a part of a seamless experience. There's a couple tools out there nowadays that, you know, sometimes they may require to upload your part or your model into the CAM software and then create your setup and then your toolpaths. But what happens if you decide to make a change to the model, right? That all that time that you spent creating the setup and your toolpaths is ultimately going to go to waste because the tool doesn't talk to your CAD system. So now with HSM, you get that integration with an Inventor or SolidWorks, right? And whatever change that you make to your model, let's say you had a setup, a previous setup, or you have already added your toolpaths to it, you're going to see that update also happen parametrically as well with the toolpaths, right? So that's ultimately going to give you a better communication or collaboration with your machinists. A lot of times, engineers and machinists, they're kind of on a different bubble, right? The engineer just makes it. Sometimes he may or may not be worried about how it's going to be machined, or he doesn't keep that in mind when he's designing. And then the machinist is going to come back to him and tell him, you know, hey, we can't machine that, or maybe you need to increase the fillet.
It's actually impossible to make.
Right. So then oftentimes, right, that's when an integrated tool like HSM comes in handy because, like I said, once you do those updates, those toolpaths are going to change as well. And we'll go ahead and demonstrate that in a little bit here.
Yeah, so like Alex mentioned, I forgot to keep clicking the PowerPoint here. So the engineer is going to be able to send that information to the machinist. And that's all built into Inventor, right? And Alex will show that pretty shortly. And so if the machinist is like, hey, I can't actually machine that because, you know, our machines are 3-axis, they're not 5-axis, or, you know, just, I don't have a tool for that, or things along those lines, right? We hear sometimes pretty often. With tools like Inventor, even tools like SolidWorks and Fusion, you can build pretty much whatever you want. Whether or not that's actually feasibly machinable or manufacturable is another story. And so this is the case where, you know, you might have some issues working in this, you know, cyclical workflow. So right now I'm going to go ahead and give Alex the reins on the presentation so we can go ahead and show off his pretty Inventor over there. And we're going to go ahead and jump into the CAM environment now. So Alex, go ahead and take that away.
All right. So just let me know if you can see my screen.
Yep, you're good to go.
All right, perfect. All right, so before we do get started though, for those of you that don't know, HSM does stand for high-speed machining, right? So along with HSM, you do get all the advanced toolpaths that come with it. So one of them being adaptive clearing, right? So you may have heard of adaptive clearing here and there, but that's really the industry-leading high-speed machining strategy, right? That reduces, essentially that reduces your mill time and extends the tool life. And we'll jump into a little bit of how that toolpath is able to do that. Right, so here in Inventor, we see that we're in the modeling workspace, right, or we're in the modeling tab. Notice here that we have this CAM tab also, like Nigel mentioned, you have the environments tab, right? But here for us, when we do download HSM, we have the CAM tab. And once you do start creating your toolpaths, you're gonna get this little tab over here that ultimately has all your setups and your toolpaths. Right, so it's very intuitive for the user to follow. If we take a look here, we're going to start from the left, right, creating our setup. Then we're going to go ahead and jump into adding our toolpaths. For those of you that have 5-axis machines, you do have multi-axis milling, right? So that's multi-axis contour that you can take advantage of when creating some of these complex shapes. Let's say you have a couple lathes at your shop as well. You do have turning capabilities built into HSM as well. Now, one very neat thing about this is the tool library, right? So HSM does come pre-equipped with hundreds of tools here, but why am I going to scroll through all these tools that I may or may not have them at my shop floor? You do have the ability, if we take a look here, to create your own custom tool library. That way, you can add the tools that are custom to your shop floor or the tools that you have available to you. Right, so once you do all that, you're going to want to take advantage of the simulation as well, right? You want to leverage the simulation inside of HSM, and ultimately what it does, it shows you the toolpaths that you have laid out. You want to make sure that you have no collisions or you have no unexpected toolpath movements when you go ahead and you run your part over there. So if we take a quick look too here, If you're new to CAM or if you're just new to this interface in general, you get this tooltip, what we call a tooltip. Essentially what it is, it's a brief description along with a dialogue picture that shows you exactly what that option is going to do, right? So it's very easy for someone that's new to maybe CAM or someone that's new to this CAM environment to get familiar with this interface.
Exactly, and the same flyouts are available for pretty much anything in Inventor, right? So if you do hover over anything in Inventor, any of the buttons in the ribbon there will be a flyout. It'll kind of describe what's going on, like Alex mentioned. That's a really good way to get familiarized with all of these, various environments that you might not have used before.
Right, exactly. So for this, we are going to want to start with creating the setup, right? We want to let the tool know or the software know exactly what size of material we're going to be cutting and where our G54 is going to be located. In this case, I have already set the stock, the dimensions for it, and I have already set the G54 location of my part, right? So very easy to follow, very easy to go about. If by any chance or by any reason I need to make a change to it, I can always go back to the operation and make edits to it. Right, so you're not really restricted to making the operation and then having to go back. Let's say you messed up, going back and then recreate that toolpath. Right, so we have a couple toolpaths here. Like I mentioned, we have adaptive strategies. Right, so we zoom in here. What really makes adaptive strategy great is this constant tool loading, right? So that constant tool loading is ultimately going to enable you to machine faster, push your machine a lot faster, while at the same time really extending the life of your tool, right? So if we take a look at the tool path, we don't see any sharp turns, right? Any sharp spikes, which ultimately give you those high tool spikes and which equals the wear of the tool, right? So by having these smooth transitions and this constant tool load, that's what enables you to really push your machine faster, right? So we take a look at this adaptive toolpath. We notice that we get these 5 tabs on the top, right? And those 5 tabs are going to remain consistent throughout all the toolpaths that HSM has to offer. So we see that we have our tool tab. We jump over to our geometry tab. That's what's going to control what areas we want to machine. Your heights tab, maybe we don't want to machine all the way to the model bottom, the bottom of the model. Maybe we just want to machine to the bottom of this pocket, right? You have the ability to control that as well. Mm-hmm. This is your passes tab. This is where you control your optimal load. Essentially, right, that's what's going to control your constant load of the tool. Let's say you do some experiments. You would probably push it more than 0.2 inches, right, or 200 thousandths of an inch, right? And then lastly, you're going to see the linking tab. That essentially controls your lead-ins and your lead-outs of the tool, right? So you can go around this part, create your tool paths. Once you're satisfied with the tool paths that you have laid out, you can go ahead and simulate, right? Let's go ahead and simulate the tool paths that I have. You can speed up the simulation if you want. Right, and point being that you get ultimately a peace of mind when you go ahead and you run your machine, right? You're not gonna be worried about, okay, maybe I didn't program this right, or maybe I might have a collision when the machine rotates. By having the simulation in hand, you have that peace of mind that your tool paths are going to work properly, right? So here we get a visualization of what the part's going to look like. We do see that it pretty much simulates it exactly to what we were expecting to see, right? All right, so then once you're happy with that, the last step, of course, is going to be post your program. So let's go ahead and post it. Now, HSM does come pre-equipped with hundreds of posts already, so more than likely you're going to find your post here for your machine. Let's say in this case, though, we're going to be using a UMC 750. The neat thing about this, though, is that it does come pre-equipped also with user properties. So if we take a scroll here, we can see some of the user properties that are already built into this post. And you can go ahead and change the values if you want to. So we scroll down here. We see G187, right? It controls the tolerance. You can enable that if you want to. You can have the machine cycle through the tools in the beginning. You also have that's also a user property. Now I know with seasoned machinists, sometimes they do prefer, their program to look a certain way, right? The neat thing about HSM is that the posts are open to anyone. Essentially what that means for you is that you can go ahead and make modifications, of course, at your own risk. If you know a little bit of coding, then this shouldn't be too hard for you to figure out. But yeah, a lot of machinists do prefer codes a certain way. I've worked with a couple customers that want certain codes or certain callouts and certain location, certain sections of the program. And that's something that we can help you guys out as well. If you ever need help or maybe guidance with your post, feel free to reach out to us, and that's something that we can definitely help you out with. Right. So once we're ready with that, we've already looked at all the user properties. Last step is going to be to post it. Let's give it a name. Give it a program comment if you want to. Save it. Right, and then we get here ultimately the code. We do see that it is 5 axis, right? So we do see that we get the B and C axis now enabled. I know for a lot of machines, you will have to do some modifications to start enabling that those 5 axis capabilities for your post. Okay, let me just scroll down here. Yeah, so yeah, that's the code for the entire program that we just did a setup on. How are we looking on time, Nigel? Are we still pretty?
We're looking okay. There's a couple of questions that I want to go over too. We have questions like, can HSM be used for forming/bending sheet metal? So, Alex, correct me if I'm wrong, but HSM is only used for the CAM aspect, both milling and turning. If you do want to do some sheet metal bending, there is a sheet metal environment built into Inventor. As well as Fusion now, right, Alex? That came out not too long ago.
Yeah, absolutely. So let me go ahead and jump into Fusion real quick then. Yeah, so you do have the ability to work with sheet metal now in Fusion 360, right? So what you can do here then is do your sheet metal part, create a flat pattern for it, and then just transfer it over to or jump over to your CAM environment and create maybe a water jet or plasma toolpaths for that sheet metal part.
Yep. So yeah, you'll use HSM for like the cutting aspect, or Fusion, I guess, for some of the cutting aspects. But in regards to just creating those bends, and creating that bent part and generating flat patterns, so you can send those DXFs to your water jets, or plasma cutters, I guess. You do that in a separate environment. Alex, do you want to mention something about Fusion and how it does the same things pretty much as Inventor does as well?
Yeah, absolutely. So if we take a look here, we notice that we pretty much have the same workflow, right? So, and that's the reason for that is that HSM is built into Fusion 360. So that's what's ultimately embedded inside of Fusion 360 and controls this CAM environment. So again, starting from the left, creating your setup, adding your toolpaths, simulating your toolpaths, and then again posting your code, right? So we go ahead and right click on the adaptive. We see that we get those same exact 5 tabs, that same exact workflow, right? So you get that consistency in your workflow, and that way you don't have to be guessing like, okay, maybe where is this option, or where am I going to locate this other option to maybe change the height of the tool? You already know right away where that's going to be.
Yep, the engine in both Inventor and Fusion is pretty much the same in regards to HSM. So if you do learn one, you pretty much end up learning the other pretty quickly. The buttons are actually almost exactly in all the same places too, which makes everything a little bit nicer.
Yeah, and cool, often I get the question of okay, what should I use, Inventor or Fusion 360? And really the way I see it is why not use them both, right? Inventor could probably help you out with certain things, and then you might find that Fusion 360 can help you out with certain other parts of your project, right? So use them hand in hand. You're not really limited to just working with one software. So I definitely recommend you trying them both.
Yeah, if you have any questions on like what to use for what, if there's a better use case for you and your company for Fusion over Inventor or Inventor over Fusion, let us know. We've helped a lot of customers kind of decide what is best for them. Inventor still obviously does a lot of stuff that Fusion can't do.
Right.
And Fusion makes a couple of those things that Inventor can do a little bit easier in some cases. So yeah, if you have any questions about that, let us know. We can answer those as well.
Yeah, so with that, Nigel, that would be all that I was going to show today for the demo.
Cool, awesome. So I'm going to go ahead and just jump back. I'm going to go ahead and take the PowerPoint back from you. Sorry, Alex. Let me go ahead and make myself the presenter here. Cool. So we went over this workflow with Alex in regards to engineering to machinists. Like he showed, it is fully integrated into Inventor. So it really is easy for the machinist to go, hey, you know, edge number 6 is an issue. I can't actually machine that. Or, you know, we don't have the tooling to be able to do something this finite and things like that. So it is really easy for them to pass that on, as well as the engineer. You know, if they do make, like Alex mentioned, a change in the geometry, it's not too drastic, right? You just change like the size of a fillet perhaps, or you change, you know, the length of a line. A lot of that does carry straight over into the CAM environment. You don't really have to change anything. You just have to update the toolpath. Obviously, if you make a huge geometry edit, like you get rid of like an entire section of your part, the toolpath might not regenerate properly or as intended. But it really depends on the on what you're changing, right, Alex?
Right, absolutely, yeah, and like you did mention, if it is a pretty big drastic change, then yeah, you might have to go back in there and just reselect the geometry, right? But it's much better than going back and creating that entire setup that you already had for your part.
Yeah, creating it from complete scratch, right? Even if it's only one
Right.
section that you're fixing. Awesome, awesome. All right. So you've probably heard this from Lauren. You've probably heard this in a lot of emails, but Autodesk is giving you their best Inventor, so you can be able to, you know, get the most out of your workflow and just become, you know, as efficient as possible in regards to these workflows, right? So we'll start from the left there. Designing and engineering, that's pretty straightforward. That's Inventor's bread and butter. You're going to design, you're going to engineer your parts, you're going to create, you know, drawings, you're going to create 3D PDFs in some cases to be able to send to the shop floor. You have built-in simulation tools, and not just static stress. You do have fatigue, you do have thermal stress, thermal strain, you do have composite laminate materials as well. Super powerful in regards to that. Like Alex showed a couple minutes ago, you do have 2.5 to 5-axis cam. You've got milling and turning, which is super awesome. And you know, you do have hundreds of posts already built in. And I think that's one of the most mature parts of Fusion itself too. So if that's something you're using, all of the same tools can be used in Fusion. You do also have factory design utilities. That's another animal in itself, right? That's probably going to take a whole webinar to even show the beginnings of factory design. It's straight built into Inventor, right? There's, like I mentioned, there's that whole catalog of factory parts that you can go ahead and drop into your workspace, be able to, you know, send that stuff out to things like Navisworks Manage and get a full walkthrough of your factory. All built into Inventor and all included in the collection. In addition to just workflows in Inventor, right? You have workflows outside of Inventor, but all in the collection, right? So they wanted to be able to give everyone access to all of these things as needed, right? So electrical mechanical interoperability, what does that mean? That's the workflow between Inventor as well as AutoCAD Electrical to be able to create your wiring diagrams, create some of these 3D representations of your actual electrical parts, right? Using things like cable wire harness and Inventor, part of the routed systems tools to be able to do that. 2D to 3D interoperability down there. There have been a lot of improvements over the last couple of years in regards to bringing some of that legacy 2D AutoCAD data, or even from other sources, into Inventor, right? So there are some DWG underlay technologies in Inventor to be able to bring some of these legacy drawings in. I see it being used a lot for sheet metal, You can bring in some flat patterns, and you can be able to generate that 3D geometry pretty seamlessly by using some of the tools built into Inventor. Moving on to the right side, right? You do have reality capture with recap, right? So you can go ahead and go to your factory, you can go ahead and go into your facilities and be able to do a full scan of your facilities and be able to get a proper 3D representation So you can be able to accurately, place all of your components in there instead of, I know it's a little silly, but just taking like a bunch of tape measures, for example, and start measuring an entire facility. It's probably not the most efficient way to do things. And lastly, large-scale design review, right? So things like using Navisworks to be able to look at your actual files in the space that they're going to go into, right? I've seen this used a lot for factories. You can see your products move across the conveyors. You can use products like 3ds Max to be able to render a lot of these and get animations for your factories. We've actually working with a couple of customers on things like this to be able to have them sell more of their products, right? It's not necessarily like, hey, let's work faster. It's obviously you want to be able to, end goal, be able to sell more products or to become more innovative. And a lot of these tools in the collection allow you to do that. So definitely you do have access to them if you have collections. And if you don't have a collection, there's a lot of easy transitions to get to a collection from things like perpetual licensing. And there are a couple of questions about that, so I'll definitely address those here pretty shortly. But if you do have any questions, go ahead and type them in now. Alex and I are able to address those as they come in. And then go ahead and jot this number and this email address down for any future reference, right? And you should be able to go through a lot of this stuff. So let me go ahead and just pull out the questions real quick. Alex, do you know if we got any from some of the other streams?
No, we haven't gotten any yet.
Cool. So if you're watching this on YouTube or you're watching this on Facebook, go ahead and type into just a comment or whatever, and then that'll get sent over to us from the man with the plan, Mr. Eric Paul. Shout out to him. He makes this all possible on the back end. So let's go ahead and take care of some of these questions, right, Alex? First off, if you have a perpetual license and move into the collection, but decide in the future to not continue with your subscription, do you maintain your rights to previous perpetual licenses? So the answer to that is no. When you do an M2S, you trade in your perpetual license for access to a subscription license, and I believe it's 30% off for the term. So that is something to keep in mind. If you need some more clarification on that, Adam, definitely let us know. We can get you on the line with one of our sales representatives or renewal reps, and they can go over that whole process with you, what you do have access to, what you don't have access to. In most cases, if you do have Product Design Suite Ultimate or Building Design Suite Ultimate, any of pretty much the Ultimate Suite, transferring to a collection is actually beneficial. It's actually cheaper to go to a collection than it would be to pay for your maintenance. So you get more tools for less money, and I'll take that any day of the week pretty much. We do have a couple more questions here. Let's go ahead and take some of these. Do you guys have training for Nastran? So what is it? So we do have training for Nastran. We actually just filled up the most recent class. So there are no slots in that, but I think we're doing a class next month. Eric Paul, if you want to message me, give me those dates real quick here for the next Nastran training class. Definitely let me know in the chat box there, Eric. Thank you. In regards to current promotions for perpetual licenses or just for old licenses in general, there is a current Autodesk promotion that lets you trade in an expired perpetual license. So I know a lot of people out there have had perpetuals for quite some time, and maybe they have a license that you're not using. Go ahead and let us know. You probably got an email in regards to saying that you're eligible to do that, right? But you can trade those licenses in for a new subscription at 30% off or up to 30% off, depending on what you're getting. So if you're interested and want to know if you do have any eligible licenses to trade in, a lot of times they're even licenses that you aren't even using. They're just tied to your account from many years ago. You can use a lot of those as well. Awesome. So let's see here. Eric just mentioned to me the Nastran class is currently scheduled for October 16th and 17th, but it may move based on room availability. So our training facility might not be available that day due to some other stuff. But it's tentatively October 16th and 17th. That might move a couple, but it is probably going to be around mid-October for the next Nastran class for those of you if you need to know. And we'll probably send an email in regards to that as well. So for people who are interested. Let's see here. Cool. This question for you, Alex. What is the difference between Fusion 360 and Fusion 360 Ultimate, and what do I get with the collection?
Yeah, so really the biggest difference between Fusion 360 Ultimate and Fusion 360 is the 4 and 5 axis cam that you get, right? Fusion 360, you do get the ability to do 4 and 5 axis cam, as well as nonlinear simulation in Fusion 360 Ultimate. So if you would like to learn or know more about those different options or those different packages, definitely reach out to me and we can go more into detail. But yeah, the biggest difference is being 4 and 5 axis and some nonlinear simulation.
Yep, definitely. And then Ken, you mentioned there, is there a way to know ahead of time for the subject for each week's AVA presentation or even our other presentations? So yeah, there are a lot of resources for that. We do give everyone the reminder on Wednesday of the week, but if you want it earlier than that, there are ways to look at that, right? We do have some landing pages that you can go to and see all of that. Generally, I like to mention the next week's presentation during this week's presentation. But yeah, you can go to kativ.com/AVA, and there's a short calendar of events going on there. Obviously, a lot of those dates are tentative. We can't go forward too far because there's a lot of schedule changing. But generally, the next 2 weeks are pretty much set in stone. So you can go ahead and look there. That's kativ.com/AVA, and there should be a future sessions tab at the bottom. In regards to that, next week, we're going to be going over the thin client or the web client in Vault Professional, right? And so you can get some of your non-CAD users access to some of those release data files if they need them for things like marketing or sales and stuff, or even in the machine shop. That's sometimes on the shop floor that happens a lot of times, that they need access to those files, but not necessarily the IP of your entire CAD data, right? So if you need that information on that class, you'll see an email from that next Wednesday, and you will be able to look some of that information up on the landing page when I update it this afternoon. Cool. Let's see here. Training in Europe, Denmark, and in Europe, or Europe/Denmark, you have training there. We don't do training live from Europe, from anywhere pretty much outside our Brea offices, unless, you know, one of our instructors flies out to a customer site. We've definitely done a lot of that before. We've done some training in the Philippines that way. We had one of our engineers fly out there and train a bunch of users on Vault.
I would definitely volunteer to go to Europe and do a training session though. I'm
sure Alex would with me. But we do have online training, right? If that's not feasible to be able to have you fly out to America or for us to fly out to your location, we do have online training at the same time, right? So you can sign up for the class in person or online for any of our training classes, pretty much. And we do use this. We do use programs similar to what we're using right now for this webcast. So you just log on and be able to interact, right? But it allows you to turn your mic on as well, so you can talk to the instructors. It's pretty much the same experience. A lot of our customers do utilize that for standard training. All right, another question. Is that 30% discount for the duration or just the first year? The 30% discount for the M2S, which is maintenance to subscription, if you're doing at time of renewal, switching from maintenance to subscription, that applies to the duration of that subscription, right? So if you do a 1-year subscription, it applies to 1 year, but if you do a 3-year sub, it applies to all 3 years. So if you need more information on that, Michael, let me know, and we can go ahead and answer those questions for you online, or actually offline. Let's see here. I'll give everyone about 30 more seconds to answer any questions. Alex, do you have anything to add while we're waiting for some last-minute questions to come through?
No, that's pretty much
awesome. So just want to remind you guys, you do have access to all of this. If you need help installing it, being able to find it in your account, reach out to us. We do have our Lifeline team that's more than happy to be able to jump on the phone, make sure that you do have access to the tools that you have access to, or be able to let you know, like, hey, you do have like a renewal coming up. You can switch to the collection and be able to get a lot of these tools available to you. So with that, anyone who shows up to the Autodesk user, go ahead, Alex.
Yeah, so there's a question. How good is HSM CAM for wood parts? I guess to machine wood parts. and the answer to that is it's great. You can definitely go ahead and apply those same toolpaths that we were talking about to those to any materials that you may be machining.
Yeah, I know one of our colleagues, Brian, uses Fusion, which uses the same HSM as Inventor does, to parts on his CNC router, and at some ridiculous feed speeds. Brian, if you're watching,
he's learning CAM, so he's still on the trial phase of his errors. So
exactly.
we're guiding him. We're walking him through it.
Exactly. Yeah. So if you do have any questions in regards to the workflows, right, or best practices for both Nastran In-CAD or CAM in general, or anything in general, right, go ahead and let us know. We can give you our insights on a lot of this. We've seen a ton of situations, and we've gone through a lot. Me specifically, I've gone through a pretty decent amount of CFD simulation. So if you have any questions on some of those flows, I do a lot of external flows, what I'm pretty much familiar with. Definitely let me know, and I can give you some insight on some stuff there. So with that, I think thanks everybody for joining us. Hopefully you do start using some of these tools, and definitely go ahead and respond to that survey afterwards. It helps us be able to prioritize what comes next for AVA. So with that, again, Alex, I'd like to thank you for being online with me today.
Thank you for having me.
Yep, and then Eric, I know you can't speak because you're on mute, but thank you for being here every week. Just a shout out to you. And with that, looking forward to another great AVA session next week, and we'll see you all on the flip side. Thanks, everybody. See you later.
Thank you. Have a good one.